Yes, welcome back to Torsion Engineering Academy. Still, we are continuing on our lecture series on the particular topic in strength of material called torsion. So please do subscribe so that you don't miss any video. Subscribe to Torsion Engineering Academy. So let us continue with our problem number 3. The problem says, calculate the maximum shear stress and the rate of twist of the hand-operated drill with the bit diameter of 4 millimeter. So that means our D is going to be 4.0 millimeter. Okay. Yes. So in this case, remember, if we put standard, that means this is 4 times 10 raised to power negative 3 in terms of what? In terms of meters. And the resistant torque T is given to be 0.3 Newton meter. That is already the standard unit. So we're taking our shear modulus G to be equals to 75 gigapascal. Gigapascal simply means times 10 raised to power 9 Newton power per meter square. That is Pascal. Right, so what is the question? The first question says we have to calculate the shear stress. Calculate the shear stress tau. Then the second question says calculate the rate of twist. So the second question is quite interesting because we're calculating the rate of twist. Twist is theta and it rotates power per length. So the rate of twist will be theta per length. Okay, so let me start by doing the first question. Remember the torsional equation, T divided by J is equals to G theta out of L is equals to shear stress divided by what? By radius. This is where we're going to solve our problems. So if we know T, our T is 0.3. Then divide by, I told you last time how to get what? D. How to get J, I mean. So J is pi divided by 2 and then times R raised to the power what? Power 4. Then you equate this to what? Now if the question, they have given me what? This. G is given. And then theta is not given. Okay. So if the question now wants me to find what? Shear stress, the first question, that means I have to consider what? With reference to this. Now this is going to be equals to J, but our J is not given. We are finding that. Then divide by R. R is not given, but we know diameter. You know, radius is equal to diameter divided by 2. So that means I'm going to have 4 times 10 raised to power negative 3. Divide this by what? By 2. So this is the same thing I have to do here, radius. So that means I'm going to have 0.3, which is this. Then I multiply by 4 times 10 raised to power negative 3. Divide this by these 2. Okay. Then I'm also dividing it by what? Pi by 2. Then times radius is diameter divided by 2. My diameter is 4 times 10 raised to power negative 3. Divide by 2, the whole of this thing is raised to the power what? 4. And I will equate it to what? To tau, which is the shear stress. So our first question will give us the value of what? Tau. If we press this, we are getting 23.87 megapascal. Megapascals means times 10 raised to power 6 Pascal. Right. So let us continue to do the second question. The second question says we have to find what? A resisting torque. Okay, resisting torque supplied is given to be 0.3, but the second question says we have to find the rate of twist. Okay, as I've stated here. So that means if you have to find this, from this I have to take this and this. Okay, so our T by J is equals to G theta by L. So if I need theta by L, so that means I have to bring what? G this side. So if I bring G this side, so this is going to be T out of what? Gj. That is what? Gj equals to theta by L. Remember last time I told you that Gj is torsional rigidity. So torque divided by torsional rigidity will give you the rate at which the what? The twist is happening. So if you to substitute here, you'll get the answer straight away. So allow me just erase this part. I can erase this part. Hope we can remember. Yes. Can erase this part. So our theta by L is therefore going to be T, which is tau 0.3 divided by Gj, which is torsional rigidity. So Gj is 75 times 10 raised to power 9. That is for gigapascal. Then multiply by J, but remember J is pi by 2, then times R to the power 4. But R is diameter, which is 4 times 10 raised to power negative 3 divided by 2. So this is our R. So raise all the things to power 4. So if you press very well with your calculator, theta by L, which is the rate of twist, is going to give us the answer that you have to press from your calculator. So according to my calculator, I am coming with 0.159. So this is 0.159. Standard unit is what? Is radians. Now this is radian per meter. So you can also what? Give this answer in degree per meter. So if I want to change this to degree per meter, 0.159, I have to multiply by 180 and divide it by pi. This is when I'm changing it to what? To degree per radian. So what is the final answer? It is 9.11 in degree power per meter. So this is our final answer for the rate of twist. So if the question asks you to find the rate of twist, so this will be your answer. If the question was to continue to ask you to find the torsional rigidity, that means you would only get what? Gj, the value of Gj. G times J is your torsional rigidity. So for this problem number 3, it was quite simple. This is the final solution we have obtained. This and finally this. So don't forget to subscribe to Torsion Engineering Academy for more problems we're yet to solve. So we're going to continue with solving more. So see you in the next question. Thank you.